Wood composites is a growing field of products that are increasingly present for a variety of applications, with an undiminished upward trend now for very many decades. In general, two main and distinct groups of wood composites exist, namely, strictly speaking, just wood panel composites and the rest, this latter being glulam, finger joints, etc. In general also, a wood composite is a composite in which the wood is in a markedly dominant proportion. Particle board, a flat hot-pressed wood composite panel composed of randomly oriented wood chips bonded by hot pressing, by using thermosetting adhesive resins, mainly urea, formaldehyde, melamine, urea, formaldehyde, MUF, phenolic resins, PF and TF, and isocyanates, PMDI. The board is generally composed of three distinct layers, the surface layers being composed of finer wood chips than the coarser core layers. Some processes yield a continuously chip-size graded board, along the surface, core, surface thickness. The panel generally has a density of 650 to 700 kilograms per cubic meter, and the average amount of resin solids in the board core section is of between 6% and 12% on dry wood. Oriented strand board, OSB, a flat hot-pressed 3 layers wood composite panel composed of oriented wood wafers bonded by hot pressing, by using thermosetting adhesive resins. The very thin wafers are oriented in the same direction within the same layer, and at 90 degrees of each other in adjacent layers, yielding a particularly strong panel very suitable for structural applications. It is the modern competitor of plywood, but at a much lower price. The lower surface area of the wafers, in relation to other types of panel, yields panels that need to be bonded with only 4 to 5% adhesive solids on dry wood. Medium density fiberboard, MDF, a flat hot-pressed composite panel composed of wood fibers, obtained by thermomechanical wood pulping, and traditionally bonded with an adhesive to a density of around 750 to 800 kilograms per cubic meter. It is a panel mainly bonded with urea, formaldehyde resins, and used for furniture and interior use. Hardboard, high-density fiberboard, a flat-pressed wood composite panel, composed of randomly oriented wood fibers, obtained by thermomechanical wood pulping, and traditionally bonded without any adhesive by hot pressing simply by the very high density, 900 to 1,100 kilograms per cubic meter, and the high temperature-induced flow of the lignin component of the fibers. Panels containing a small amount of adhesives, generally PF resins, are often produced today to upgrade the properties of the panel. Plywood, a flat hot-pressed multi-layer wood panel, composed of oriented wood veneers bonded by hot pressing, by using thermosetting adhesive resins. Laminated beams, glulam, parallam, scrimber, and finger joints, a flat-pressed multi-layer wood beam, with thick wood planks constituting the layers, used for structural exterior applications, and bonded with PRF cold-setting resins, or MUF cold-setting resins, or even with certain types of polyurethanes, especially single-component PURs. The individual wood planks are bonded to the necessary length to compose the beam by finger joints bonded with one of the same 3 adhesives above. The most current big volume wood composite adhesives are briefly listed as follows. Urea formaldehyde (UF) adhesives are the adhesive dominating the wood panel composites market for the preparation of interior grade composites used for furniture and a wide variety of other applications. An approximate volume of 11 million tons per year of these adhesives for wood are used worldwide. Melamine is an expensive chemical. Thus, today, these resins are traded as melamine, urea, formaldehyde, MUF resins of equal performance as the older pure melamine, formaldehyde, MF resins. They are of 2 types. First, MUF, thus UF resins with just between 2 to 5% melamine, that are nothing else than upgraded interior grade UF resins, this being also one method of decreasing a UF's formaldehyde emission. Second, exterior and semi-exterior grade MUF adhesives containing between 30% to 40% of melamine. Phenol formaldehyde (PF) adhesives are, by volume, the second most important wood composite adhesive, with up to 3 million tons per year being used worldwide. They are fully exterior-grade adhesives to bind truly weather-resistant wood composites, and extensively used for particleboard, OSB, and marine plywood. They dominate where panels are used for housing, but have traditionally had the defect of having slower curing at higher temperature than for MUF adhesives. The progress has been considerable also in these resins, with PF adhesives now pressing as fast as MUF resins. PRF adhesives are cold-setting adhesives. They are expensive, due to the high cost of resorcinol, that gives them their characteristic to cure at ambient temperature. They are thus used for glulam, finger jointing and similar products, and for ambient temperature made LVL. The term bio-based adhesive has come to be used in a very well-specified and narrow sense to only include those materials of natural, non-mineral origin, which can be used as such or after small modifications to reproduce the behavior and performance of synthetic resins. Thus, only a limited number of materials can be currently included. These are tannins, lignin, carbohydrates, unsaturated oils, proteins and protein hydrolysates, dissolved wood, and wood welding by self-adhesion. A recent approach to wood composite binders is based on glucose and sucrose-based non-isocyanate polyurethanes (NIPUs). The finding that glucose and sucrose reacted with dimethyl carbonate and a diamine to form NIPU resins has led to the application of these resins as wood panel composite adhesives, with very encouraging results.